Hey, it's a quick little vid over the Hooke's Law Lab. So what you have to do is graph the relationship between force and stretch on a spring. So I got a 140 gram mass over there. You can select any mass you want to. You can make it bigger or smaller. Maybe you like even numbers. You want to go to 100. Fine. So I can put a 100 gram mass on there and whoo, where it bounces. So if you want to get rid of that bounce, you can just hit this stop sign over there. Now, a couple things that might help you are what is the unstretched length of the thing, which I should have showed you before I put that on there. So before I put the mass on there, that was the length of the spring. Now this would be the resting position when it's not vibrating, but I can find that pretty easily just by hitting the stop sign up there. So what you have to do is graph the relationship between force and stretch. So first of all, it's a 100 gram mass. That's not a force. On planet Earth, well, first of all, that would be a 0.1 kilogram. Then times 9.8, that'd be a 0.98 newtons would be the force. So remember to change this to weight, but you got to be in kilograms to do that. And secondly, you need to find it per the amount of stretch. You want to line up your ruler and find out, well, what is the amount of stretch? Then when you're done with that, take that off and put on it. Actually, you don't have to take it off. You can just leave it on there and you just change the mass over here and regraph it. Go ahead and stop the sucker, and that's the resting position. Measure your new amount of stretch, change the mass, hit your stop button, same story over. Take as much data as you need until you can have a relationship between the force you put onto this spring and the stretch. You do need a line of best fit onto there, and you're going to have to find the slope of that line. So you can do this for two different springs, okay? So to get a different spring, you can change the spring strength from 1, you can change it to 2, through whatever you want to do. So you have a difference, or maybe you want to make it way different. Maybe you want to go clear down to here. Same story. So remember, you got to change this to weight. So 0.16 kilograms times your 9.8 would be the force acting on it, and then there'd be your stretch. So do a second graph of the other spring, then you can compare the two slopes and the shapes of those two graphs. Do use the same scale on both graphs so we can visually look at it and tell the difference between the slope of which one might be steeper than the other one. So do put a conclusion onto this. Conclusion is why is there a difference in slope? What's going on there? And that's it. It's not a full write-up on this one. Okay, due on Wednesday.